so my name's Greg Crutsinger. I handle and work with a lot of our agricultural companies that are using Planet data. And so today I want to walk through an agenda, which is just an overview of Planet satellite data. And then I'll talk about some of the traditional use cases that we've had for satellite data in agriculture and specifically. And then I want to go into some new use cases that I think are particularly interesting, and then future directions. Where is Planet headed next, and what can you be excited about? And there's a lot going on at Planet in the coming months and coming years. So I'm excited to give you a little bit of a preview into what's headed next. Okay, so let's talk a little bit about Planet. We have been around since 2010. So here's the classic Silicon Valley garage shot of the team. And really we were launched for agile aerospace. So thinking about rapid prototyping and development of constellations that can image the Earth. And we've come a long way from this picture. So now we have offices in a couple of locations around the world and not stuck in the garage, but it's interesting to see those early pictures of where Planet has come from. I want to walk through a little bit of our one of the major priorities of Planet, really around the industry, which is Planet images the whole world every day. And our three goals are really to make change visible, accessible, and what's more key is actionable. So you can visualize all of the information, we can provide it to users, but it's really around what decisions can I make around imagery. That's a key aspect of making use of imagery. Here I'm going to show you just a quick video of our constellation. So our main constellation is our Dove satellites, and these are small satellites, so that, you could pick them up and carry them around. They're in a sun synchronous orbit. So here you can see them, and they're actually acting like a line scanner around the Earth. So they're taking pictures roughly around solar noon. They're always on, and they're at 3-meter resolution. And they have different bands. Right now we're at RGB and NIR, but we actually have more bands than that on our newest Super Doves. We also have a high resolution product called SkySat, which we have 21 of those satellites orbiting, and those are at 50 centimeters. Now those are task satellite products, so they're not always on just scanning the entire Earth every single day. They're more for more precise targeting. Once you look at some of the general patterns, the texts have changed, you can task a satellite to get those 50-centimeter higher resolution images. So here's just a lot of statistics I'll throw at you, but basically we are taking around 4 million images every single day. That's 25 terabytes of data downlinked from our satellites every single day, going to ground stations that are distributed throughout the world to download all of that information. And then we package it all and stream it out to our customers. And so there's just an insane amount of activity that happens for all of our teams, from building the satellites, launching the satellites, tracking them in space, taking all our imagery, and then piping it out through our analytics. And so it's incredible to be part of Planet and see all these pieces working in action. So here's our Super Dove satellite. So this is what it looks like. So you can see basically it acts like a telescope, and you can see the antenna kind of sticking off there, but this is what they look like. And I want to walk through just some of the bands that you can see. So this is more from a remote sensing perspective. We have 3 different versions of the Dove, so we're always evolving in the design. And the first design had RGB bands and a near infrared, but we've slowly narrowed those bands to be more precise within each channel of light that's coming out. And so the Super Doves now have 8 bands associated with them. So we're in the visible spectrum. We have blue, green, yellow, and red. We also get into the red edge, which is interesting from an agronomic perspective, and then near infrared, which is really important in terms of thinking about plant science in general. And these align with Sentinel-2. So Sentinel is a part of the European Space Agency constellation. It's publicly available data. And so we align with those bands, and that's important for thinking about compatibility between Planet with more open data from the government and merging all those layers together. And so that's one of the key aspects about Planet, is leveraging some of the more publicly available data and Planet data together, and they're complementary. So here are Planet products. We have a range of different products, but the key one is PlanetScope monitoring off to the left. So that's that always on monitoring from our SuperDoves. And so that's scanning the Earth, and that's available and basically streamed in for daily imagery. And that's really, to me, I mean, I'm biased because I work in agriculture, but I feel like Planet was built for ag. Like daily imagery of the Earth's landmass is just a key agricultural product. We combine those scenes that are collected from PlanetScope and we create base maps. So we have global coverage of these base maps, and that takes the best pixels for a quarter or a month or a week and combines them together into a map. And to me, that's a useful product for looking and really detecting change over time and visualizing it as a base map. We also have our SkySat tasking, which is that higher resolution tasking that I talked about. And then I'll talk a little bit about some of our newest products, which is around Fusion, which is a cloud-free, uninterrupted daily radiometrically consistent data product. So that all means basically we're tracking every single day in a model or a data analytic product, these Fusion tiles, which really track the phenology of the entire growing season at a very high level. It's a very next level product. You can access our data through, we have user interfaces. So we have our Planet Explorer web app that you can log into, and you can load up your field and you can look for all the available imagery. We also have plugins with some of the available GIS software like QGIS or Esri products like ArcGIS. And then you can also create your own data pipelines that flow directly into your apps. So we have customers that use our data API, which allows you to search our entire catalog, orders API, which allows you to customize how you want to order and pipe in the imagery. Or we also have a newer subscriptions API, which is basically, let me take my field and let me plop it down as an area of interest. And you just automatically deliver data to me. I don't have to create an order and search for the data. It just says, here's my field. Why don't you send me everything as it comes about? So that's a little bit of a rundown. That's kind of the standard breakdown of Planet products. I want to go through some of the traditional use cases now for satellite data. So in general, when we're starting to think about remote sensing, we've been using remote sensing in ag for a long time. But Planet data has a particular edge in terms of where our strengths are at and how it applies to satellite data in ag. And in particular, we have that 24-hour daily monitoring. And this is important and really gives us a competitive edge in regions where there's high cloud cover. For example, in Latin America, where it's tropical, it's really cloudy. You want to get that information in when you're trying to do a lot of different management applications. And so if you're just relying on publicly available data and it happens to hit cloudy days, you're getting further and further gaps in between when you can get your imagery. And Planet solves that by having that high cadence. And so here you can see, this is just an example of one area in Nebraska. You can see this is Landsat 8 and Sentinel. And you can see that there's a lot of gaps in the imagery due to clouds compared to Planet's temporal resolution, which is going to be able to really fill in some of those gaps and give you a better chance to capture an image. And that can be important when you're trying to make timely decisions, that you're not going a long time in between images. So the temporal resolution also is important when we think really when we're thinking globally as well. So we know that more and more there's connectedness within the global agriculture supply chain. And so having that frequency and being able to capture imagery at that global scale, especially with the cloud issues, becomes increasingly important as you deal within crops or across different varieties of crops. And I think as we continue moving forward, it'll become more and more important. So that's the cadence. That's one of the key aspects of Planet. One of our other strengths then is going to be our resolution for agriculture, including for small scale farms. So here are smallholder farms. So Sentinel data is at about a 10-meter resolution. And what that means is if you look at a given pixel size, the smallest unit that you can see in the pixel to the farthest left, it's going to be about 10 meters on each side. So 30 by 30 feet or so. So a fairly coarse resolution. Planet's at 3-meter intervals. And so that allows you to really see at higher resolution within a given field. And then even higher at satellite, at SkySat data, which is about a 0.5 meter resolution. And so you're really getting finer and finer scale. And at some point you would have to move towards aircraft or drone imagery to get much finer scale resolution. So this basically allows us to do a lot of in-field variability monitoring. And so we have a lot of partners and customers that are doing this. They're taking our data and you're able to map much more precisely within a field where that variability would be and do management zones and other typical applications. So as well as directed scouting. So if you're seeing issues in a field, then you can move and basically make decisions at a much finer scale, and you can do that remotely. So whether that's disease infestation and trying to track that, or whether it's applications or different seeding regimes, then you're able to really look at your field as a whole and see it from the sky and be able to see it daily as needed to see how that variability is changing based on your management decisions, as well as throughout the growing season. We can also detect issues like failures in irrigation systems or applicators or clog nozzles or other things like that. You're able to see that variability pretty well through that 3-meter resolution data. We have a lot of interest as well in cross classification. So this is getting back to that kind of smallholder farms and thinking about different crops grown across the world, but at that smallholder farm scale and what they're growing and how that's changing both locally up to regionally or even at the country level. So there's a lot of interest there in tracking crops. We have a lot of interest in governments as well, the ag agencies that are thinking about how growers are performing and what they're growing and how that's changing from year to year or growing season to growing season. So that's kind of the 3 key aspects. So it's really daily monitoring, that resolution, and then the ability to scale. So as I said before, we're monitoring the entire Earth's landmass every single day, and you're able to scale that compared to, say, trying to use a drone. I was in the drone industry for a long time, and if I could map a couple thousand acres on a day, I was doing pretty good. That was a really good day. Well, we're doing millions and millions of acres, and so you're able to scale those applications up to a global level very easily using satellites, and overcome some of those challenges with clouds that have been traditional within the remote sensing space. I also like to think about our data throughout the growing season. So we have different applications, and these are the fairly traditional applications of precision ag throughout the growing season. So everything from early season operations, so thinking about seeding or variable rate applications, thinking about crop management at kind of the peak season, so monitoring crop health, or thinking about early detection of disease, for example, or weeds, and then directed scouting. So saving you from, you're driving around a field, you're only seeing the edges of the field. Seeing it from the air gives you that fuller or complete picture of a given field or a given farm or even a given, province or country. And then towards the end of the season, as we look at dry down and harvesting, so thinking about how you plan for harvesting and manage it, as well as planning for it next year. So looking at your productivity for the year, and then planning for the following growing season. So there's a lot of those different kind of traditional applications that we've been talking about in applying remote sensing for a long time within ag. And so we're just seeing that really come to fruition as Planet has become more mature with our constellations. It's really exciting to see how our users are really applying it at scale and really piping in all of the data that we have to these various applications throughout the year. So it's the same imagery, PlanetScope imagery, but it's being used at multiple stages throughout the growing season. So to me, it's really interesting. It's one of the reasons I joined Planet is to really be a part of applying and maturing the satellite industry today. So I want to take some time and walk through the new use cases of our data. And I think these are opportunities within the satellite space to really apply it in new ways. We've talked a little bit about the traditional use cases of directed scouting and variable rate and management zones. I want to talk a little bit about some of the new ways, and then I'll get into some of the future directions of where Planet is headed next. So here are a range of use cases that I'm going to walk through, and we'll see how much time we have. I definitely want to spend time at the end going through questions because there's a lot of questions around the application of our imagery. So let's make sure that we stay on time there. So when we think about high cadence time series data, I think where our imagery really could be applied is improving yield estimations. And this is really thinking about the traditional models around forecasting and yield predictions. And here I show data from a paper. This is basically running simulations and looking at yields under different aspects of these different simulations around LAI, which is the leaf area index. It's one of many vegetation indices that can correlate with biomass of your plants. And so here we can run the simulations, and we can do that at the beginning of the season, but we can also keep running them throughout the growing season and feeding in the existing data and looking at how that affects our predictions of the end of the year yield. And so I think training these models and using our data and feeding it in and seeing how that regular cadence and that higher resolution data and the variability really impacts the simulations and really dials in the model predictions. Off to the right here, I show you two different graphs. And this is using NDVI, which is a fairly standard vegetation index that looks at reflectance off the plants. But it's a good general metric of health for lots of applications. It's not perfect for everything, but it's one of those indices that you see fairly commonly in the agricultural space. On the top, you'll see the cadence of imagery that you're getting from Landsat and Sentinel, those free data points. And on the bottom, you'll see a new product from Planet called Planet Fusion. And this is going to get you those daily points. And you can see it really smooths out the curve and the trajectory throughout the year of NDVI as we look throughout that growing season. And so what that does is just give us a better consistency of data coming in that we can then feed into those yield predictions and estimations. And this can be important for a range of different applications around forecasting and pricing of given crops. So I want to run through Fusion and kind of what it is. It's really a data science product. It's a model that runs on every single pixel within every image every single day, as well as a lot of cloud masking and things to take out the noise. And it basically looks like this. So here's PlanetScope data on this calendar. And so what it does is it basically smooths it out. We'll see if my slides are lagging just a little bit. It'll smooth it out in terms of the trajectory there it goes. And this is what Fusion monitoring looks like. So this is a model from one day to the next that's based on real imagery. It's not just fake pixels, but it's basically take PlanetScope data and filling in and smoothing on the days that we don't have an image, and then calibrating that radiometrically. We calibrate it to Sentinel data, and then take out all the clouds and cloud masking into this function. And this is basically, here's this view of what that looks like. So this is the daily imagery going throughout the growing season of one location with Fusion applied. these are large tiles. So it's not cropped to any particular field, but it's basically a tile where every pixel is running that model. I'll play it again. So it's really a data science product that's available and being used primarily by agronomic scientists that are trying to really look at the impact of how, if we can track the phenology better of given crops through time, how does that influence a lot of these applications around agronomic decisions, research, and then aspects like yield predictions. So I think as a next generation product, I think it'll be particularly important. So, and this goes along with tracking crop phenology. So here I'm showing a figure of NDVI through time. And so we can look at the different stages of the crop, and looking at phenology is often fairly important for thinking about those agronomic decisions. So things like inputs or applications that we might be providing throughout the growing season, and where timing can be really important in those decisions in terms of the effectiveness of how you're really applying your decision making. So being able to smooth out and look at the trajectories and the shapes of those curves in better ways, and how our decisions affect not just any given point, but the overall shape and trajectory throughout the growing season is really interesting. And there's a lot of different applications that I think are there and that we're seeing come out in the literature now. So we published on this, and other researchers are publishing around the application of fusion for these research questions around phenology in different crops, in different locations, at different times of year, et cetera. So one of the pain points in using imagery in ag is extracting field boundaries. And so I wanted to just bring that up. You know, fields change from year to year. I mean, I live in California. We have fields changing even within a year as they rotate out for different annual crops. So you might be growing, you know, lettuce in one part of the year and then switch over to something else at a different part of the year in the Salinas Valley, for example, which is close to where I live in the Bay Area. So extracting those field boundaries and accurately, I think, is one future direction that I see for the use of satellite data that would be beneficial, and automating that process so you don't have to go in and manually draw them or upload a shape file or some kind of boundary, and continue to do that if your field boundaries are changing from one year to the next, for example. Another important aspect is to look at green up and look at planting and harvesting dates. So when we think about tracking different management practices throughout the growing season, in the past, what we did is basically look at when there was green up enough that we could detect it in the satellite data, and then back calculate when that planting date might have been. And that can be important for a lot of different applications. But I think that really, with the frequency and the cadence of CubeSats, the cube satellites like PlanetScope, I think that we're better able to identify basically down to the day of when that field was planted, and be able to track those patterns in a given different region, as well as harvest. And so I think that's a really important future application of our imagery. This is one of my favorite applications, mostly because I like to put pictures of cows up. But what we see in our data is a use of satellite imagery for thinking about forage use efficiency in grazing, and being able to optimize pastures and pasture management. So looking at biomass of grasses can be a fairly manual process. So I have the little stick that you put out there, and you can look at like the height of the grass, and depends on the variety, and you can estimate biomass. And you can do that for one pasture and another, and it's fairly tedious. And so being able to dial in your pastures and think about how you're, the number of head that you're stocking in there, as well as how you're rotating them around, and being able to really optimize that and automate that process is something that's today quantifiable. So basically, we have customers they're using this, or they're extracting those analytics for their users, and you can look at the yield or the amount of biomass or the amount of weight gain and see the actual changes in how this is optimizing that and what's the return on investment of using remote sensing. So improving forage use efficiency, I think, will continue to be an important application as we really scale this globally for different regions, especially under different climatic regimes when we're thinking about moisture content or rainfall or different types of animals and different types of pasture. Insurance claims, this is kind of a growing area as well, especially with the high resolution satellites like SkySat. So thinking about claims and how we start automating the process around claims. Monitoring sustainable ag practices. So this is also a really growing area as we think about sustainability initiatives. We just had COP26 in Europe. So just thinking about changing practices like till, no till, or cover crops and how we monitor those practices, as well as reporting. So thinking about how do we, make sure that we're seeing those practices and we're reporting those practices in order to have them verified by different agencies, different stakeholders. Monitoring field trials. So I came from the drone industry, so I'm obligated to put a drone in like every single talk that I give. But I think that, field trials, I've worked a lot in field trials, and there's a lot of pain and applications around just the tediousness of collecting really high resolution data and making sure that it is collected accurately. And so monitoring your field trials, sampling, and thinking about changes at a plot level and for your different treatments, I think is an important aspect of remote sensing data. And I believe that drones are really important for small scale, really high resolution phenology measurements, for example, or phenotyping. But I think satellite data can complement a lot of a lot of the measurements and the automation of the processes that we're seeing in the field trials. And so it's a complementary tool. It's an important one. And I think we'll continue to see, it's not either a drone or a low resolution satellite, it's them working together. Also field trials, I think there's a lot of opportunities in just thinking about field trials as our kind of set up established experiments, but we're also seeing natural experiments that occur. So it's something you might have done accidentally, like double applications or skipping a row, et cetera. You're able to go back into our archive data because we're always on monitoring. You're able to go back and really see, okay, here's something that happened last year. We didn't collect any data on it, but can we go back into Planet's archive because they have all of the daily imagery going back years? We can still extract that information. It's there, it wasn't lost. And I think that's an interesting application as well. Okay, just being cognizant of time, I want to go into the future directions. So that was a handful of interesting applications that I think are prime opportunities for using satellite data. Let me tell you a little bit around where Planet is headed next. So I've joined Planet. I've been at Planet just this year. So it's an exciting time at Planet as we go public. So we're going public coming soon. And so there's some things I can talk about and some things I can't talk about, but let me tell you a little bit around our future directions. So one of those directions is around a project called Carbon Mapper. And this is a hyperspectral sensor that we're using for tracking methane and other aspects around emissions and climate change. But having a hyperspectral sensor in space is really interesting, and having a constellation of them. These will be task satellites. They won't be that kind of global monitoring, but you'll be able to have hundreds and hundreds of bands or wavelengths of light. And the reason that that's interesting from a remote sensing science standpoint is now we can really start dialing in very custom applications within agriculture related to the chemistry of the plant, or maybe other aspects that we're interested in for disease or soil issues, where we can really see the properties and how those properties might change, and where you might need hundreds and hundreds of bands to get a signal from the imagery itself. So this is a key direction. it's an area I'm really excited to see us going, and I think it'll really raise the level for the future of the science. The other area that we've announced is a no high resolution satellite. So we're calling it Pelican. This will be the next generation of satellites after SkySat. And this will be a rapid revisit, high resolution satellite that'll really dial in those future applications where it's around, insurance claims or other aspects where you want a higher resolution image than the 3 meter. I can't talk too much about this constellation, but we have announced it. It is coming. It's on the roadmap. And so we'll be able to talk about it more in the coming months. The other aspect that I want to announce is that this just came out. It just came out last week, is that Planet is acquiring Vandersat, which is a company out of the Netherlands. And so this company is really interesting. It comes with a really strong agronomic and expertise and remote sensing expertise, and they'll be joining the team. And they're complementary data products. So they often use passive microwave in their products. And that's going to allow us to both see through clouds, which is something our optical sensors can't do, as well as have analytics like soil moisture and dry down, which is really interesting for thinking about complementary to the visual data where we're looking at plant health and other metrics. We'll be able to look at some of those abiotic variables that complement and really fill in some of the analytics that we need as the future of using remote sensing in the ag space. And so that's it. That's kind of the future. We're going public. There's acquisitions happening. There's future constellations happening. It's really an exciting time to be at Planet. We're also hiring a ton, so you can go to planet.com and look at all the jobs that are being posted. There's new faces popping up at Planet every week. So I encourage you, if you're interested in the plant sciences, remote sensing, sales, any of those jobs, feel free to reach out to me at gregory@planet.com. So I'm going to go ahead and stop sharing now. I'll take some questions. I'll leave it up in case we need to go back some slides, but we have plenty of time for questions, I believe. And thanks so much for listening to me be super excited about Planet Data.
Thanks a lot, Greg. Really appreciate it. And really, actually, it was very insightful for me. As I said, we had Planet present many years ago when you were just launching the Doves, and I hadn't seen I just assumed they were all the same. So your generational changes and updates has been pretty exciting. And one of the things that I had never thought about was the grazing aspect of it. And I think that's pretty cool. I think that's something that maybe the dairy or the cattle guys aren't thinking about, but can really definitely see, find a benefit of using the satellite service that you have, with especially the frequency of kind of daily date information you can get.
Yeah, and the scale, I think about these large ranches that are out there, and you're monitoring at thousands of hectares or acres, but also at the regional scale. So you can think about not just your ranch, but all of the ranches or all the regions in an area and how well it's all doing independently. I think you can really dial in and optimize your grazing that way.
Yeah, for sure. So we do have a few questions. I'm not sure if one just got answered, but let's see. So to get accurate results like disease and weed maps, how is the ground truthing should be integrated into a system?
Yeah, that's really important to think about, is that like in ag, like the imagery is just one thing. Like raw pixels are great, but it's going to take several steps to really get to okay, what's this mean from a return on investment? And a lot of that depends on the applications. How well does the imagery align up with what you're seeing in the field, boots on the ground? And so it's, for example, nitrogen content. Well, can we detect it? Well, it depends on how well the imagery is going to see that greenness in the leaf and how well that correlates with the nitrogen. And that's going to be different for corn as it is for soy, as it is for specialty crops. And so there's still a lot of work to be done on ground truthing for some of the lesser known crops, for example. in order to make those management decisions. It takes going out and aligning and correlating what's the image showing, and like, how does it relate to what I'm seeing in the field? And then what am I going to do about that? And so that's where a lot of our partners and customers are just, they're, you know, farmers aren't per se like buying our imagery. They're working with our customers and our partners to get those derived analytics that are custom for their applications, like grazing, for example, or other agronomic decisions. We pipe in the data, and there's a lot of opportunities there to take our data, customize analytics, and then provide those directly to the growers themselves. So we're kind of the, you know, the data feed into the platforms that are then gonna use it to make those decisions. They've done the ground truth work. You know, they understand what the imagery can say and what it can't say, and then they're really trying to provide the ROI to the farmer themselves.
Absolutely, yeah, that makes a lot of sense. I think the other thing that is pretty unique about you is that, one, that you're gathering that data daily, that you can stitch it together and really do a visual understanding of how things are changing over time, and you have historical data too. And I think the key when you talk about people that are just getting into precision agriculture and they go, I don't know where to get started. Well, hey, listen, there's lots of data that can, everyone knows what their yield was at the end of the year, right? Or
yeah, I have like I have a friend who actually was gonna, like, he was gonna buy a new farm, and he's interested on like, okay, look, I can go back in time and I can look at, like, you know, it was especially in some of these pastures where it's been pretty dry, and interested in like, okay, I want to go back and like, in this fairly drought period, like, what did this look like, and how can I make better decisions for this acquisition moving forward, you know. And he's it's really amazing to be able to have this catalog that grows every single day. We have around 1,700 pictures of every single spot on the Earth's landmass, like, going back in this catalog. That's an amazing and a really important aspect of Planet, and makes Planet more valuable every day as that catalog grows by 25 terabytes.
Yeah, absolutely. So we have a question from Evan. Is high resolution thermal data via satellite possible, or something on the radar, like sub 1 meter? Drones are great, but there are issues in the large.
Yeah, and thermal data is just complicated with drones in particular. You know, if the cloud goes by or the wind blows, the surface temperature of your leaves changes. I think so thermal data is important. So this is more thinking about the infrared, the heat signature. I think there's a couple of different wavelengths and bands that get at that, similar to like the passive microwave or SAR data also can get kind of at soil moisture or leaf moisture content. We don't have thermal data today. Some of the government satellites have that, and we can leverage that in our constellation and feed those publicly available data layers in. I think with the VanderSat acquisition, there's a lot of aspects that we can get around for thinking about. Mostly with thermal data, we're thinking about moisture content, right? We're thinking about drought and water use efficiency in plants. And so I'm really excited to see what we can do with that, with the expertise coming from the VanderSat team.
Yeah, I think that's going to be pretty exciting. That was great news to hear about that, and I think it's a perfect marriage of what you have to offer and what they have.
And the thermal data at high resolution is hard. You know, right now we can get it with some of the. I'm in California, so I think mostly about wildfires every fire season, basically, and it's fairly coarse at the 100-meter scale. What's publicly available, so. You know, the space world is moving really fast. We're seeing new companies all the time. So I think it'll be interesting to see around not just thermal, but all these other different spectral areas as people dial in on SAR and some of these other aspects. So it's not a boring place to be.
Got another question. Talking about grazing and silage fields, can we get data which separates legumes from non-legume grasses?
Yeah, so I get that question a lot around. A lot of it depends on the spectral signature of the different species or different varieties. If they look different, then it's easy to pick them up in imagery. But if it's like early on and there's just a few individuals at 3 meters, it's a little bit harder to see until they get to be larger patches. But it depends on basically within an image, like how distinct are they in the image, and how can you use these different wavelengths and different bands of light to really make those patterns kind of pop out and say, okay, this is what I'm looking for. And you go out there and ground truth it and say, oh yeah, like it's aligning with what I'm seeing. So I would say it's possible. It depends on the species. It depends also on the time of year. So if you can get the phenology where you're, if one comes out a little bit earlier than the other, for example, or if there's a flowering time, you can really see the flowers pop, for example. So getting that timing down often can help in dialing in that spectral, it's called a spectral signature. But it's basically like how they look in the image and whether they can pop out, and whether you can finely tune the image to really dial in their distribution of different species, different varieties, et cetera. So I think it's certainly, there are established process to give you an answer to that. It just depends on the species and how closely they align with their neighbors.
Yeah, it would make sense. And I think, so we talked about, obviously, the doves that are out there. I think you said there's about 180 in orbit right now. With the pelicans, what's the objective? How many do you think you're going to be?
Yeah, I think there's a good, on the ag side, like I haven't been, there's not a lot I can share on how many there will be, but it'll be a new constellation, probably comparable to SkySat, but having that rapid revisit rate, a lot of it's around just seeing world events happening and unfolding, which is a whole nother side of our business. And we see that pop up in the news all the time. I see planet data in New York Times and other places. So we have a whole nother world of non-ag customers. But for me, the interest is around orchards. Actually, I'm here in California. I want to be able to see a lot of individual trees and be able to distinguish those out. That's hard to do at 3 meters, but at 50 centimeters, you can start getting metrics like tree counts, the canopy size, and other metrics around that for more permanent crops. So I think I didn't talk that much about it, but personally, I think orchards there's a lot of opportunities there.
Yeah, it's obviously a little bit higher value crop as well than the row crop that we tend to live our lives in, but there's certainly lots of great information that you can gather from what you're presenting right now with the doves, and I think anyone who's not really looking at this kind of opportunities is missing out on how they can really optimize their farming operations. So I think it's
yeah, and whether it's Planet directly or it's one of our customers, I feel like there's a range of tools and analytics that are there today, and that they'll only get better. And so, satellite data has been around for a long time, but I think we're really starting to see the efforts come to fruition, and I'm excited about where it's headed next.
All right, so I just realized we're actually past our time.
We're out of time, yeah.
If you want to just finish off, Greg, just
yeah, you can go to planet.com and check us out. You can get a hold of me at gregory@planet.com, or if you're interested on the sales side, you can reach out to our sales team. But I really appreciate your time and being invited, and I look forward to seeing you next time.
And Greg, when you get some new news to share with us, please do, and we'll make sure that we get it up on Farms.com so all our attendees can find out what's new with the planet.
Sounds good. All right, thank you. Have a good day.